Welcome back to Portable Power Repair Secrets. Today we've got a Peak. Looks like it's marked Power Station 1200. Looks like a pretty nice unit. Got it from the store a couple weeks ago. It has two USB connections. They work. Has a 110 volt inverter. Has a nice air compressor with digital readout. I'm assuming that's PSI, pounds per square inch. Whoever threw this out included the charger with it. You can see we have it plugged in. She's taking a charge now. The only thing I see wrong with this unit is that the DC negative alligator clip is broken. So today we're going to replace this. See if we can't get it fixed. Now it's a beautiful day. I'm going to take it outside and do it outside. Enjoy the weather. You can't see these LEDs or any of these other controls outside because the sun is so bright. So that's why we're just giving a little walk around here indoors. Okay, I'm going to take it out, see if we can't get it fixed. Now there are two ways to approach this problem. We could try to replace just the alligator clip. For that to happen, we would need a plastic handle exactly the same physical dimensions as this one. We would have to drill out this rivet and then install the new handle and replace the rivet either with another rivet or nut and bolt and screw. The problem is I don't have a handle just like this, but I do have lots of cables in my stash, and you get these because every week there are 2 or 3 of these free for the taking at the store. So this one's in excellent condition. I don't know, you can see the copper here is not corroded in any way. It's the same wire gauge. Let's see if we can get a close-up on this. What it says here is PVC cable 6AWG, that's American wire gauge, 600 volt, 105 degree centigrade. And let's look at this one. This one says 6AWG, AWG for American wire gauge, high current power cable. It's fairly flexible. This one's not quite as long. Of course, can't really stretch it out. It's not quite as flexible, but we'll see what we can do. We have some others here. So we're going to try what we've got, see if we can't get this fixed. Now, how hard can it be? For tools, we're going to need a Phillips head screwdriver. This is a nice Harbor Freight. It has a very, very nice tip. Works very well for these kind of repairs. Need a little container to hold the screws, and then either a pair of 8mm or 5/16 wrenches. They could either be a pair of 5/16, a pair of 8mm, or one of each. Alright, let's put the camera down, take this apart, see if we can't get that cable replaced, check out what kind of battery is inside, see if there's any corrosion or other damage inside. I'm thinking we just need to replace the cable and we're going to have a very nice unit here. But we'll find out shortly. Looks like the case just splits apart in the center here. We've got 2, 4, 6, 8, 10, 12 screws. We'll start at the top here. Come on. There we go. Magnetize that screwdriver tip. Okay, so far these top four are all the same size. I want to be very careful now as we go down the case because these might be longer. We don't want to get these mixed up when we put it back together. Oh, these are shorter. That's unexpected. Okay, so we got, put those back in the container in the order that we took them out, because I'm not measuring these. We want to make sure we get them back in the right spots. Okay, the two short ones here. I'll try to shake that one out after. It's pretty tight here. Okay, we've got this opened up as best as possible. These cables are very short, but there is enough room to flip the top cover back over. And you can see that the broken wire goes right here. So all we have to do to make this whole is to unscrew this nut and bolt, attach our new cable, and we should be in business. Let's give that a try. Okay, we have a washer. Nope, this one. Have a lock washer and a nut. Have this one with some, looks like green. plastic cement on it. That's weird. Otherwise, no corrosion. These look pretty good, so we'll talk to ourselves. We have 4 on this side, and the big copper alligator clip wire on this side. Now what we have for length, comes out we're about 2 inches too short, but I think it'll be okay. So we're going to put this on. So this one had quite a bend in it, so we probably should bend this the same way. I also noticed that the hole's a lot smaller. Here's this other one. Hole's the same size, not quite as flexible. What we got for length? Oh, look, it's also a little longer. Maybe I'll use that other one. So we're going to have to bend this. Either put that in a vise or get a pliers and bend it. Okay, I'm going to use this vise because it has rubber jaws and shouldn't scratch up the copper too bad. We want to bend it towards the curve here. I only want to bend it once. Do it by hand. Maybe not. Maybe this way. Okay, how's that? A little bit more on the original. Fairly close, but I'll go just a hair more. Should be good enough. We'll try it. Thinking this had to be this way. So that green stuff looked like it was like a nail polish that's used to keep the threads from, like a very, very weak Loctite, because here it is. I don't think we need it. I don't see any corrosion here. Looks very good inside. I don't see any difficulty. Now, before we get this back together, let's just make sure the cable is good. So we have our 2024 Centec Harbor Freight meter. Again, no complaints with this meter so far. All the functions work very well for the $14 or so that I paid for it. Almost as good as the original red meters, which were only like $8 or $9 back in 2010 or 12 when they came out. But this one's very good. Has a lot of features that the red one, even the original red one, did not have. So I've got it here on the diode test, so it's going to beep when we touch the probes together. Simplest way to see if we have continuity in this cable, you know, we put it in without even testing it. So what I'm going to do, now watch these probes, because even though you've got two jaws on the alligator clip, only one jaw is powered. This jaw has no power going to it. So we want to touch this one, the one that has the wire on it. So we're going to touch that one. See if we can hold it there. And touch this. We get a beep, so that shows that juice is going all the way through the wire from this little juice is being provided by the 9-volt battery that's in here. And we can actually measure the resistance of this cable. So I'm going to put it on 600 ohms. This is very important. What we're doing now, we're going to put these two leads together. We bring it to 0. So this is telling me that the resistance of the test leads is, according to this meter, going to read 0. So we don't have to subtract anything. Now I'm going to hold it against the powered jaw and hold it here. So we have half, well, see if I get a good contact. It's pretty good. With good contact, I got no resistance in this cable, no measurable resistance. So should be good to go. Let's put it back together, see how it works. Air compressor cable's fighting us a bit. I'm thinking it's there we go. I'm gonna get the light caught in its little container here. The red cable coming through here. All right. Okay, we're just going to flip it and get a couple of screws in it. You want to be careful on putting these screws in. So you want the seam to close up, but you don't want to go past that because it's just plastic and you'll strip it out. So we've got a pretty good closed seam there on the top. And a couple of screws that stayed in on the bottom, so we'll just tighten those back up again. Well, hopefully this black cable is going to be long enough to reach. Already got the air compressor cable tucked in. It's still about an inch short. It does clip. There's a little space here to clip these cables. Okay, they're both clipped. See if the light works. Light's working. Air. Air's working good. Digital readout is good. Close that. Test the battery. Oh, we're down 1 bar. Charge it up. Not bad. Yeah, she's coming off. I'm happy with that. Okay, we're back here in the garage. It's the next day. We've had it on charge all night. Hopefully we didn't boil the battery. And now we'll do a function check. But before we do, I did mark this charger, peak jump starter. And although you can't read it because the writing is so light, this is a 12 volt 500 milliamp charger. So that's half an amp. Now the plug, in case you don't have one of these and you're looking to match it up, this is positive center, meaning that the red wire would go to the positive and the black wire would go to this shell here. Positive center. Now how do we prove that? Alright, we're going to plug it in. We'll put our meter on DC volts. We have to have a scale that's higher than 12 because we're going to be measuring 12 volts. So we put it here on 60 volts because that's only 6,000 milliamps, or that would be 6 millivolts, so that would be 6 volts. And if we tried to measure this voltage here, we'd get a 0L, meaning overload. So okay, 60 volt scale should measure 12 volts, no problem. Going to turn on the light, that helps. Flip out the stand. This is that cheap new Harbor Freight meter. A lot of nice features for what they're charging for this. Okay, so we've got it plugged in. Now, let's see what this reads. I'm going to hold the black test lead to the shell, just holding it there with my thumb. Can't get shocked. There's no difficulty with a little charger like this. And I'm going to put the red one down the center. And what does the meter say? Meter says we're putting out 13.44 volts. And notice to the left of this one over here, there is no positive sign or negative sign. So the absence of a negative sign means that we have the positive probe in the center, and that would be correct. Now what if I reverse it? Watch what the meter tells us. We get the same voltage, but notice the negative sign in front of the 13. So this is your no load voltage of the power supply, and that would show you that you've got the probes reversed, and that actually you've got negative center right now. What we want to charge this is positive center. So the official charger is 12 volts, 500 milliamp. Now that would be, in case you don't have one of these, that's exactly the same as the charger that came with the yellow Harbor Freight made by Zundian Power Supplies. So it's called the 5-in-1 portable power pack. 12 volts DC, 500 milliamps. These power packs are interchangeable. Either one would work here. Now, if you don't have one and you're not inclined to make one, I wouldn't recommend getting anything like this. You're much better off and these are cheap. This is called a float charger. So on sale, these are $7, $5.95, $6.95. And you would not plug it into the charge jack here. Instead, you would clip these alligator clips onto those alligator clips, red to red, black to black. And you would turn this to on. Now the thing about a float charger, these are the types of units that we would use on snow blowers, lawn tractors, motorcycles, quads, jet skis, anything with electric start that you don't use that often, generators. And what this does is this keeps the battery fully charged without overcharging it. So what happens is when the internal battery drops to, in my experience, I'm measuring about 11.5 volts, maybe 11.3 volts. This kicks in and charges it and brings it back up to full operating voltage. And as soon as it's back up to 12.8, 12.9 volts, which is where you want it to be, this shuts off. So it's constantly monitoring the voltage and only turning on when it needs to turn on to keep this fully charged, so it's always fully charged when you need it. This is a much better deal, and they're cheap and they work quite well. Now, the problem with leaving these chargers plugged in, some power packs have float charger circuitry built into it, and the owner's manual will tell you you can leave this plugged in 24/7. But most power packs don't have float charger circuitry built in, and the manuals will tell you only leave this plugged in for 3 to 5 hours. If you leave it plugged in any longer than that, you're going to boil the battery and ruin it. So I know the Harbor Freight yellow power pack is like that, meaning this one. Yep, I really like these, but this model does not have float charger circuitry built in. You can't leave the power pack plugged into this. After the initial charge, fully charging the power pack by a DC connection will take about 12 hours. Do not exceed the maximum DC charge time of 12 hours. So, in my opinion, if you don't have a charger for the power pack that you rescue, and it takes a DC style because it's got this little jack, doesn't take an AC cord, you're much better off. In fact, no matter what it takes, you're always much better off with a float charger, especially when the power pack does not have float charger circuitry built in. Now, which ones have float charger circuitry built in? Well, in my experience, a lot of the Schumachers do. Some of the DieHards do. You have to read the manual. Once the battery is fully charged, the built-in charger automatically switches to float mode monitoring, which trickle charges the battery and keeps it fully charged without overcharging. So, the portable power 950 may be permanently connected to the wall outlet. So I don't know if this does or not. I'm thinking that it doesn't. And I got that right. According to the Peak Owner's Manual, notice, do not exceed maximum recording AC charge of 40 hours. And so that's why if I wanted to have this ready to go at a moment's notice, this is the charger I would have on it. A float charger. Now, the problem with these float chargers, some of them cause AM radio interference. This one does. So we have a whole episode on that. You would want to test this while it's charging with a little AM radio. And watch that episode, and if you're getting that kind of interference, you want to exchange it for one that does not do that. So yeah, the good and the bad. Great battery charger, but not if they knock out the whole neighborhood's AM radio. Not good. We're living in a strange world. Everything is so complicated. But okay, let's see how we did. Now we've got our meter on 60 volts. We've got this turned on. We're going to touch the probes to the alligator clips to see where this battery is. How well did it take a charge? I want to touch the lower jaw on both sides. There you go. 12.9 volts. That's exactly the same as if we were charging this with a solar system. 12.9, perfect. That's 100% charge, right where you want it to be. So we did have it on charge all night. I was using this one, so perfect. All right, now how about a function check? Okay, we know these are good because we just measured 12.9 volts. Turn that off. Hold the tissue here. Let's see if the air compressor does anything. Plenty of air coming out of the air compressor, so that's good. All right, let's test the USB. This is what you would use to charge your tablets and cell phones and anything that takes a cell phone charger. 5.09 volts. It's going to read no amps because we're not drawing any juice on this little meter. So this is working good. Well, what about the AC? Let's try that. See if that works. How's that? This is a little gooseneck lamp. Have it plugged in here. Works perfectly. All right, now, a lot of people say you shouldn't trust these outlets in a portable power pack. So let's just measure it. Let's just see how well this one is doing. And to do that, I'm going to turn our meter over to AC volts. AC volts are down here where the tilde is. So we're going to be measuring 120 AC volts. So we'll put this on 600. Measure 120 just fine. And we're going to use Steve Jerzik's suicide cord. This is a guy I worked with many years ago, made this up, and Steve, if you're listening, I still use it. Now I've got some shrink tubing here. They don't call it a suicide cord for nothing. I'm going to cover those connections. Make sure they're separated. They're covered. We're on AC volts. I'll turn the light on. Does that make it better or worse? And there's our voltage. 116.8 with no load on the outlet. And that's pretty good, because line voltage here is about 121. We talk about 110. So that's very good. 110, and also known as 117, also sometimes referred to as 120. Light just went out here. So that's excellent line voltage. Some of these run very low and they're below 100 volts or near 100 volts. That's not good. You don't want to run your appliances and TVs and things on low voltage. This is excellent. Right on the money where it's supposed to be, 116.7. And we're not overheating. The fan has not come on, so we're hardly pulling any juice from this battery at all right now. Quite impressive. Very impressive performance. Well, another power pack saved from the trash. I'm happy to have it. I hope you found this useful. Thanks for watching.